Back page, I'm glad you're continuing on. First one on the back page here is it's literally dividing, and that's the same as, remember, division. Like in your past, if you had 3/4 divided by 2/3, you can't cancel across division, so what we'd have to do is turn it into multiplication. Well, we always keep the first fraction the same, we turn the division into multiplication, but then we flip it. We take the reciprocal of the second, so it'd be 3/2. Then we'd cancel if we could. Well, the one I just did real quick doesn't, so the answer would be 9/8. Okay? Well, that's what we got here. I mean, if we can try to get this highlighter here, we've got a division right here. That's what we got right there, division. So we're going to turn that into multiplication, okay? So what I'm going to do is leave the first fraction exactly the way it is, but I'm going to factor it as we go. Again, factoring could be the hang-up, but positive sign here means both signs are going to be negative because the middle sign is negative. So I have an x minus and an x minus. Factors of 6 are 3 and 2, and I try those, and those actually do work perfectly for that when I OI that problem. Okay, bottom left, we're keeping that the same as well. Definitely throws kids off. They try to do guess and check, try to do difference of squares. It's not. Literally keep it simple. Take an x out. So if I take an x out, I'll have x times x plus 3 sitting right there. Okay, remember now, I'm going to change this to red. We need a multiplication sign. Okay, now it's multiplication. So when I go to the next part, I'm going to have a fraction for sure, but these two right here are going to be flipped. We're going to have to flip those because it's the reciprocal. So as you can see, the 3 minus x, that's going to go on the bottom. Okay, so we're going to have 3 minus x on the bottom, no factoring to be done there. And this is going to go up top, and I'm going to factor it at the exact same time, and that would be GCF of 4 coming out with x plus 3 in there. All right, so here we are. I hope you watched the other video, which really, again, reiterated what happens when you have something like the x minus 3 and the 3 minus x. When they look almost the same, but they're not quite with that subtraction sign, make one of them a 1, make the other one a -1. That's the only time we do that. All right, what about x plus 3? If you take the x plus 3 and the x plus 3 and cancel them, boom, we got it. And I look across, the only thing on the bottom is an x. I do have an x here, but it's with the binomial, so I can't do anything. So if I have this -1, this +4, and this here, we can clean this up nice and neat and say -4 parenthesis x minus 2. And then on the bottom here, we're going to have just an x. Okay, not the prettiest answer ever, but that is as far as we can go with this problem. Okay, number 14 here, top left. Again, top left, 2 terms. There is a minus, but it's not a difference of squares right now. So what we got to do is take out the GCF. 3 comes out, but also an x comes out. So look at what happens here. This is going to get a little intense. 3x comes out, which leaves x squared in there to make the 3x cubed. There's a minus. And the next number is 9. Well, here's where it gets a little intense. You got to keep going with this. You got a GCF out, but now this, and this is going to get a little crazy here with it. Oh, let me not do that. That was very hard to see. Hold on. I'll pause for you to understand it. But this right here turns into, I'm going to cross that off. That's a difference of perfect squares. It turns into x plus 3 x minus 3. Very intense, but that's all. Everything I've done so far is the top left of this problem. All right, now bottom left of this problem. I know you're not the fave. It's not your fave when there's a 2 there, but this isn't going to be that bad. We've got our minus sign on the back end. See that? And a plus sign here. Doesn't matter because they're going to be one of each. So we put a plus and we put a minus out here. Now, with no thought considered, I'm just going to put a 2x and an x here, because we know it has to be 2x squared. And then a 3 and a 1. So I'm going to slap a 3 there and a 1 there. Let's see if that works. When I do my outside, switch colors here. When I do my outside, I'm going to get -2x. When I do the inside, I get positive 3x. That's a grand total of 1x. So what that tells me is that's not combining to the 5x, so I did it wrong. It's okay. I'm going to take away this blue and I'm going to try again. So instead of a 3 in the first slot and a 1 in the back, let's try a 1 here and a 3 there. So let's see if that works out. So I put a 1 here, 3 there. All right, so here we go, switching again. When I do the outside, now I get negative 6x, and the inside I get positive 1x. Combines together to negative 5x's, negative 5x's. Well, when I look here, oh, I wanted a positive 5x. So what's that mean? We got to switch these signs right here, right? So I'm going to take this off again, okay, back to here so there's not too much work on the screen. But this one really should have been a minus, and this one really should have been a plus, which is going to make a difference when we factor, or I'm sorry, when we cancel in a minute. Okay, remember, we have to divide, so we're going to flip the next fraction. So the 9x squared actually goes to the basement. And then up top here, I'm putting 2x plus 1, 2x minus 1. If that was too fast for you, I'm sorry, but that's a difference of squares, and I've seen a lot of those, so I want to take care of those. 2x plus 1, 2x minus 1. All right, let's get green here and start canceling. X plus 3 is going to be tricky because it's up here. X plus 3, see ya. Oh, 2x minus 1, 2x minus 1, see ya. So I got ones here, one there, 3 over 9 becomes 1 over 3. Oh, x over x squared. That's bottom heavy by 1x. So I can't, there's a lot going on there, but there's nothing else I can cancel. So in blue here, final answer, look at the top. We have on the top x minus 3, and then in parentheses we have 2x plus 1. We have all of that on top, and on the bottom the only thing left is 3x, and I can't simplify any of that stuff because of the binomials. All right, I hope that helped. All right, I'm going to do 16 and 18 here. Hopefully I will be doing an okay job for you. But the biggest thing you got to look at when you do these is that we're totally switching gears here. Please see this, like when you're taking your test. We're totally switching gears to this thing called synthetic division. So what we want to do in synthetic division is set up that problem, remember, that looks like this. And then we got to look right here. This has an x squared. This is very, very important that you see this, okay? This has, move this over a little, x squared. Then there's an x to the first power, and then there's a number. There's no gaps. We didn't jump from like x to the fifth to x squared. We have no gaps. So when there's no gaps, that's awesome. So what we do is we just set up our problem with the coefficients. So I'm going to have a 9, I'm going to have a negative 53, and I'm going to have a negative 11. That's what I'm going to have across that way. Now remember, switch colors here. X minus 6, we take the opposite of what we see here, and that goes right over here. So if we see the minus 6 there, it's going to be a positive 6 over here. All right, first thing we do is pull down the 9, multiply back. 9 times 6 happens to be 54. So multiply back, and then add down. So adding down, I get 1. And then we multiply back. 1 times 6 is 6, and then I add down, and I get negative 5. This we circle and we call our remainder, and then we're ready to finish the problem. I hope you can really rewatch this a few times if you don't understand it, but there's numbers that are left here. That's where we get our answer from. Well, there's no variables. We have to fill that stuff in. Again, where do we start this problem? With a 2. So if we started with a 2, whatever's 1 less than that, which is just an x, that's what we start our answer with. So we have 9x plus 1. And then we have a remainder here. So I'm going to add my remainder, which is negative 5 all over x minus 6. And then that right there would be our final answer to this problem. Okay, if that wasn't perfect, I'm going to do another one with you right here on the bottom. The biggest thing we got to notice on this one, and I'm not going to rewrite it all, but I want you to think about this. See the x cubed, then the x squared? It jumped to 7. We missed one here that had just an x term. So we have to put a filler of 0 in there. So going with the coefficients, there's a 1 in front of the x cubed. There's a 4 in front of the x squared. And then we're missing that one, so we have to put a 0 in there. And then we have 7. So what number goes over here? Take your best shot. I hope you are. Okay, and then that would actually be, since it's x plus 1, we would put a negative 1 there, opposite of what we see. Now when we take this down, we have a 1. 1 times negative 1 is negative 1. Adding down, we get a 3. 3 times negative 1 is a negative 3. Adding down, we get a negative 3. Multiplying back, we get a positive 3. And adding down, we get a 10. Circle it. What's that called? You said it. Remainder. And then final answer we can do here. this is the coefficient for our answer. Since we started with an x cubed, our answer will be x squared to start with. So 1x squared plus 3x minus 3, and then we add that remainder, 10, all over that x plus 1 that we had at the beginning of the problem. So that would be the answer to this. Okay, I really hope this helped. I'm glad you watched. Good luck.